Okay, so this is exercise 12G in our textbook, which is integration of circular functions. Okay, what do we remember? We remember that when function of x equals sine kx plus a, then the derivative of that is k times cos kx of a. And also when function of x equals k cos x plus a, then the derivative is k sine kx plus a. So let's do that in reverse. Now we want to find the antiderivative of sine kx plus a. Well, that is 1 on k minus 1 on k cos kx plus a plus c. Remember the plus c? Remember the plus c. I'll just get a little pen up here. Remember always, this is an antiderivative, so we're always, when we anti-diff, we're getting a plus c. Now let's do the antiderivative of cos kx plus c with respect to x. That gives us 1 on sine kx plus c. Okay. Important. We're talking about angles measured in radians. If they ask the angle in degrees, this doesn't work. This doesn't hold for us, so we're dealing with radians in this situation. Okay, here we've got our first example, number 1. So number 1, 3 sine 6x with respect to x. Take the 3 out the front, and then we'll do the antiderivative of sine 6x. Antiderivative of sine 6x is minus 1 on 6 cos 6x plus c. Gives us the 3's cancel. 3 cancels with that to give 2. We end up with minus a half cos 6x plus c. Okay. Next one I'm going to do is 2 cos x on 4 with respect to x. First thing again, take the 2 out the front. Cos x on 4 dx. Now x on 4 is the same as 1/4 of x. So x on 4 is the same as 1/4 x. So that's going to become 2 outside of 1 over 1/4 sine 1/4 x plus c. 1 over 1/4 is the same as 4, so invert and multiply. Sine x on 4 plus c, which gives us 8 sine x on 4 plus c. That was number 2. Let's try another one. Let's do number 3 now. This time I've got minus 2/3 cos 2x plus 1 with respect to x. What am I going to do here? Well, the minus 2/3 comes out the front. Cos 2x plus 1 with respect to x. Then I'm going to say, well, the minus 2/3 stays out the front. And this is going to be times 1/2, 1 over 2, sine 2x plus 1 plus c. Don't forget the plus c. Okay, what happens here? The 2's cancel. I'm left with minus 1/3 sine 2x plus 1 plus c. Okay, so there's our antiderivative. What about if we had a definite integral? The definite integral is when we have our antiderivative, cos x dx, but we have an upper and lower limit. So our lower limit is pi on 3 and our upper limit is pi on 2. Well, antidiff cos x is sine x, and we want pi on 2, pi on 3. What does that mean? Substitute the x's in. So upper limit sine pi on 2 minus sine pi on 3. Upper limit minus lower limit. Well, we know what the sine of pi on 2 is 1. The sine of pi on 3 is root 3 on 2. So 1 minus root 3 on 2. Let's do another one of those. Let's do another definite integral. This time, I think we're up to number 5. Let's do between 0 and pi, sine of 2x dx. You could stop the video and do this yourself before I get there if you like. What's that going to give me? Well, it's minus a half cos 2x, but I've got my limits between 0 and pi. So minus a half cos, I'm putting pi in where x is, so that becomes cos 2 pi, and then I'm minusing minus a half cos of 0. What do I end up with? Well, minus a half cos 2 pi. Cos 2 pi is 1, so that becomes a minus a half. Cos 2 pi equals 1. Plus minus a half cos of 0. Well, cos of 0 is also 1, so that becomes plus a half. So that equals 0. This one now, this is number 6. We want to find area under the curve, and we've got this situation here where we've got pi on 4, 5 pi on 4, and 9 pi on 4. And this is a graph of y equals sine x minus pi on 4. Okay. What do we know about this? This part's going to be positive, this part's going to be negative. So area, the total area, is going to be the area between 5 pi on 4 and pi on 4 of sine x minus pi on 4 dx, plus, now how do I make this positive? I'm going to put the limits the opposite way. So this becomes the upper limit, 5 pi on 4, and this becomes the lower limit, 9 pi on 4 of sine x minus pi on 4 with respect to x. What do I get? Well, it's going to be minus cos x minus pi on 4 oops, round brackets, square brackets, and upper limit 5 pi on 4, pi on 4. And then we're going to plus, and it's going to be the same thing again, minus cos x minus pi on 4, and this time upper limit, lower limit. Well, let's bring that up here. What's that? What have I got for me? We've got, that gives me minus outside the cos of 0, cos of pi, 5 pi on 4 minus pi on 4 gives me 4 pi on 4, which is pi, minus cos of 0. And that's my first integral. My second integral becomes minus outside cos of pi again, plus cos of minus cos of 2 pi, and minus 1 plus 1 plus 1 gives me 2, plus 2 gives me 4 square units.